Okay, so now we're going to move on to chapter 3, decimals. If you thought fractions you didn't like, now we're into decimals. Really bad stuff. But actually, it's not so bad once you get used to it. But the decimals and fractions are definitely related. And we show you how to go from one to the other and back again. One of the first things we're going to talk about in decimals is something called place value. My pen has been acting up a lot lately, more than usual. Here you go. So we're going to place value. So this will be our decimal right here. And if you look at the right hand side of the decimal, it's going to be tenths, hundredths, thousandths. It's the VH that I can never get through, and 10,000s, 100,000s. If you go to the left, we got the ones. Same, we're used to this one here. We're really used to this one. Ones, tens, hundreds, thousands. Awesome. The thing is, you should notice that if we're going to the right hand side in this direction, there is no ones unit over here. So it starts at the tenths. Same as that one. So there's no ones unit on the right hand side of the decimal. And you'll hear me say things now like, okay, I'll just pause for a second and show you some terminology that you're going to hear me using in the next little while. If I say to the right hand side of the decimal, it's this side of the decimal. If I say behind the decimal, it's this side of the decimal. If I say after the decimal, it's again this side of the decimal. So there's probably three ways you'll hear me refer to that way. It's always on the right hand side of the decimal. So if we were to read this number, it'll be 104 and 99 hundredths. So in case the book goes on to something a little different now, and they go on to talk about writing decimals in words. I think that's pretty apparent, pretty common sense kind of thing. So I'm not going to spend much time on that. I'm actually not going to spend any time at that. It's basically, if you know the place value, you can actually determine how to say this in words or in numbers. So, and if you have any trouble with it, come see me, but I don't think anyone's going to have any problem with that. So I want to move right on into the next section, which is rounding. So I'm just going to review the rules right here. And we'll do some examples. So just cutting out the pieces that I want. Rounding decimals are rounded in healthcare to create manageable numbers we may have a difficult time visualizing the number that looks like 14.39757. However, it looks better if we just say 14.4 or whatever. And so in this case, we're rounding to the nearest tenth. So how do we do rounding? In order to do rounding, you also have to keep in mind the place value system. This one back here. Come on. This one back here. Keep in mind these place value settings, these numbers here. And for example, rounding off to the nearest tenth will be one decimal place, hundredths, thousandths, tens, hundreds. So you have to keep this in mind when we're doing any rounding. And the rules for rounding that we're going to be using is right here. Underline the place in which you are rounding. Like in this case here, they're taking 1.75, rounding it to the nearest tenth. Looking at our diagram, the nearest tenth is one spot after the decimal or behind the decimal, so it's right to the decimal. And that's where we're going to cut it off. Then we notice that if it's 5 or greater, we're going to add 1 to the tenth, and then drop the numbers after it. So for example, the 1.7 turns into 1.8. If it's 4 or less, we leave the 1.7 as it is and drop the numbers up behind it. Alright, let's try some examples down here. Let's try. Get this in a second. Look here. Alright, so let's look at this one. I'll put the place value chart there just so we keep it in the back of our minds. And I'm just going to set it up here, on the page. And this one here up. So we're rounding off to the nearest tenth in the first one. Where are we rounding off to? What number? Any ideas? .25 to the nearest tenth. So if we're confused, look at the chart up here. You see the nearest tenth is 1 decimal place to the right of the decimal, right there. Which means we're going to be rounding off where the 2 is. So it becomes 7 point what? Okay, if it's 5 or greater, we round the number up, so it becomes 7.3. Once again, we have 245.39. One round off to the 3, and there's 10th. Look at the number behind it, and it's actually 9. And my pen is acting up again. And 9 right there. So because the number at the right hand side of the 3 is greater than 5, we round the 3 up, and that becomes 245.4. The next one's pretty tricky because it's 0.95. We're going to round it off to here. So we round up or down. It's 5 on the right hand side, so we round it up. So 9 becomes 10. So the actual answer here would be 1.0. We have 3.825. We're still rounding to the nearest 10th, so we're rounding half to the nearest 8. Not that boring, is it? We're finishing up some work here. So basically now we look at this one here. It says this one's a little different because it says 3.8 and the number to the right hand side is a 2. So this stays at 3.8. Does not round up. And we drop the numbers behind it. Do not do this though. Do not. Let's just say, for example, if I had 3.845. Do not do this. So we're rounding this one off to the nearest 10th, rounding off to here. Do not look at the 5 and say, okay, that's a 5. That's greater than, that's 5 or higher. So let's round this 4 to a 5. Now that's a 5. So let's make this 8, a 9. So it's 3.9. No, don't do that. That's motoring pain. So all you do is look at the number immediately to the right of where you're rounding off and decide where you round up or you round down. Make sense? Let's look at one a little more challenging. You can go over there. I'll make it go over there. So this one is round to the nearest hundredths. A little bit different than the last one. This one is like, you notice the 100th place is two places behind the decimal. We're going to raise the decimal right here. So 1, 1, 2. So we're rounding off the first one to the nearest hundredths. We're rounding off to right here now, to 5. See the difference? Before it was 1 decimal place, now it's 2 nearest hundredths. And once again, we're going 18.358. We're going to look at the 8. 8's greater than 5. So we're going to round it up to 8.36. This one here is tricky again because it's 8, 9. So we look at the 9, which we have to round a 9 up by 1. So this one comes 0.90. The next one, we have 4.29. The one behind it is 0. So we just go with 4.29. The number 4 is 0.0650. running off to the nearest hundred. It's going to be right there. This is behind the number. For the number on the right hand side is a 5. So the 6 becomes a 7. 0.07. And we drop the rest of the numbers. And the last one we want to do is right here, 0.0074. We'll round it out to that 0 right there. So it's going to be 0.01. That's not too bad, I don't think. I think we're kind of used to rounding. Is that fine for rounding? Awesome. So let's have a little chat about comparing decimals. And we'll look at this example I give in our book first. So, which one is larger, 0.081 or 0.0288? First thing we should do is line them up. You can see right here, line them up so that the decimals coincide. Right here you can see how I'm saying the decimals are here, one on top of the other one. And then we have a look at the numbers. So the line with the decimals line up like buttons, buttons on a shirt. This will help make the decimal numbers appear to have the same number in the decimal places. So you see there. Add the zeros to fill in empty spaces if you need to. Really, like putting the 0 down here really doesn't matter that much, really. Wouldn't worry about it. Because you can still tell which one's larger, the I and the 0. But it makes you feel more comfortable. You can add the 0. And then you look at here, it says disregard the decimal point for a moment. Read the numbers as if they were written like normal numbers. So it would be 81, 280. So 0.28 is larger than 0.081. I don't necessarily do it that way, because simply all you got to do really is look at the numbers from right to left. Right to left, and see which ones are the largest in that order. And right away you see that the 2 is larger than the 0, so the 0.28 is larger than the other number. Alright. Let's try some examples from our book. Number 1, in practice 5, we have 1.2, 1.02. Which number is larger? Oh, sorry, it says which number is smaller. My bad. I'm just changing the rules, you know. I don't like that rule. I'm just making my own rules. No, which one is smaller? Well, if you look at these numbers here, the decimal point is here. The first number after the decimal is a 2. And the first number here after the decimal is a 0. So the smaller number is going to be 1.02. The next one, we have 0.075 and we have 0.75. So the first number after the decimal is 0 here. And here it's a 7. So 0.075 is the smaller number. This one is kind of more tricky because we have 0.425 and we have, 4.25 and we have 4.25. But this one here has extra numbers, which makes it a little larger. So the smaller number will be 4.25. Once again, the last one, number 4, 0.4 and 0.04. Again, the 0 here makes this one smaller, 0.04. And down here we have 0.033, and we have 0.3. So basically, this one here will be smaller because it will be a 0 where the 3 is here. If you were to line them up like the same to do it, it will look like this, 0.0033 or 0.03. And you see, this one here will be larger because the number up here is 0. So the number there will be 0.0033 is the smaller number. Cool. Down below, practice number 6, which number is larger? Kind of the opposite of what we just did. Looking at number 6, number 1, in practice 6, number 1, we can see that it's going to be 0.0895 or 0.89. Well, there's a 0 after the decimal here, which makes that one smaller, which makes this one here larger. Looking at this one, number 2, there's a 0 right there, so this is 0.497. This is 4, so that's the larger one there. Number 3 says 0.6 or 0.06. 0.6 is larger. We have 100.75 and 100.07. This would be a 0 after the decimal. This is a 7. So this one here is larger. And the last one is going to be 0.069 and 0.6. So this one here is going to be larger. 0.675. Sound good? Any questions on that? Which is larger? We're just looking at the decimal place, or where the decimal is, and seeing what numbers are larger or smaller around the decimal. Alright. Moving right along. We're breezing through this. Alright, this is some fun stuff. I'll use my backup pen because this one's getting on my nerves. So let's talk about fringes and reading fringes. Finally, something that looks like you might see in the profession. And there's a trick to reading fringes because you have to know what the scale is on the fringe itself. You're like, what? Ring scale. Well, look at the first syringe right here. We can see that it's in mils, and it goes up to 12. So it's each one of these is a mil. 1, 2, 3, 4, and so on. So that would be a mil. But you can see inside here, say between 1 and 2, or let's say between 2 and 3, each of the little dashes in here, how much are they worth? How much? They're going to be a decimal because they're smaller than 1. But how much would they? What would the value of each one of those markers be? How would you tell? Any thoughts? Trusting that you guys get this right, because if you're going to be giving me a needle, I want you to know that you're going to give me the right amount. All right? So let's make sure we get a good grasp on this stuff. Okay? So how will we determine that? Look right here, you can see that there's 1, 2, 3, 4. So there's 5 points to go from, 5 steps to go from 2 to 3. So each step has to be. Okay, let's look at it this way. I don't want to get too complicated with the math, but let's just have a look at it this way. If I have 2, this is 2.1, 2.3, 2, 2.3, 2.4, I'm only get to 2.5. So each one of those can't be 0.1 because it's too small. How about this one here? If I have 2.2, 2.4, 2.6, 2.8, 3. So each one of these little dashes are worth 0.2 mils. Make sense? So how much is in the syringe? 1.6. Right on. 2.6 mils. The next one, notice the difference in size. The next one is 0.5 mil syringe. So inside here, you'll notice that there's 10 dashes to go from 0.4 to 0.5. What are each one of those dashes worth? Any thoughts? So it's if we're going from 0.4 to 0.5, that range there, and there's 10 dashes. In the middle. What do you think they're worth? Because this would be 0.41, 0.42, 0.43, 0.44, 0.45, and so on. So how much is in this range? You can make it larger if you want to see it larger. .4 what? Now, hang on, I'm just going to go back, make it a bit larger even, for 1 second. And make it larger again. Let's blow this right up. So what I'm trying to show you here is this piece in here. These little numbers in here. So this would be 0.4, this would be 0.5, so this would be 0.01, 0.02, 0.03, 0.04, 0.05. So right here would be 0.44. So it's really important to determine the graduations or the measurements on the syringe to know exactly how much is in the syringe. Because you notice that up above each one of those little dashes was 0.2 mils. Now each one of these little dashes is 0.01 mils. Big difference. Oops. So this one would be 0.44. And how about the one on the bottom? This is a 1 mil syringe. This is 0.5 mil. But notice that the markings in both these syringes are exactly the same. So what would the number of mils be in that syringe with that arrow? Yep, exactly right. 0.32. Perfect. So, next point here is we're getting close on our time, but I'll just introduce this concept and we'll come back to it tomorrow. Or no, we won't. We'll come back to it on Monday next week because it's Friday in the test. So just look at this piece right here, adding decimals. Adding decimals is going to be pretty good as long as you remember one thing, and that piece is right here. To add the decimals, first line up the decimal points and then add them. So this means that the problem presented in a horizontal pattern like this, take it and rewrite it like this in a vertical pattern. What you do, you line the decimals up to see how they're not lined up. You line them up so you have 2.32 plus 0.14, and you just add them up. So what will be 2 plus 4 is 6, 2 plus 1 is 4, the decimals are right here, and the 2 just stays right there. This pen doesn't write quite as nice, but it's more reliable. Two, 1, 4, 6. Awesome. Any questions on that? Pretty basic. The key is lining up the decimals. Right there. Well, we got a few minutes, so let's do some practice with this stuff. Actually, I'm moving smaller. So for number 1 here. Number 1 says 0.8, so I have 0.8. Now I have 1.5 with no decimal, so it's going to be 1.5. The decimal will be behind. If you want to put a 0 back here, you can, no problem. And this will be 3.5. So notice how I took them from the horizontal pattern to a vertical pattern and lined up all the decimals. So now it's great. Now just add them the same way we would add any numbers and disregard the decimal. The decimal just comes straight down like this, so you can put it there first if you want to, so you don't get confused. So 8 plus 5 is 13, same as adding the regular. 3 goes in here, 1 up here. 5 plus 1 is 6, and 3 gives us 9, and the 1 comes down here. So 19.3. Let's look at number 2. We have 10.25, 12, the zeros in there, just keep everything lined up. We have 0.75. Notice once again, I'll line up all the zeros. Line up all the decimals, and now we just add them. 5 and 5 is 10, so that gives us 0 here, carry 1. 1 and 2 is 3, and 7 is 10 again. Once again, 0 here, carry 1. And we have a 3 and a 2. So it's pretty basic, pretty simple. It's just regular adding. As long as you remember to line your decimals up, you're in good shape. Just to the last one. Looks like this. We have 3 and 3, 0.15, 3, 2.00, and 0.15. Let's add them up. Again, you see the decimals are all lined up in a straight line. Being neat and particular when it comes to this kind of stuff is important. Keep them all lined up. 5 and 5 is 10, so it's going to be 0, carry 1. That's going to be 3, 2, and 3. And that's it for adding decimals.